Hello students, welcome to Narayan PU College online classes. So in the last class, we have discussed about the types of hybridization. In that one, first we have completed Sp3 hybridization, and second one is Sp2 hybridization. Clear? Or we can call it trigonal planar. This trigonal planar indicates the shape of this Sp2 hybridized orbitals. Clear? Previously we have discussed the Sp hybridization are linear. Linear means what is known? The shape of Sp hybridized orbital is linear. And here also the shape of Sp2 hybridized orbital is trigonal planar. This indicates the shape of the molecule or shape of that hybridization. Clear? So what is the previous same what we have discussed definition for the Sp hybridization, the same for the Sp2 also. But there Sp hybridization means one s orbital and one p orbital are mixed together and form two new Sp hybridized orbitals. New orbitals, that new orbitals we will call as a Sp hybridized orbital. But here one s orbital and two p orbital of the same atom mixed together and forms three new equivalent orbitals. Equivalent orbitals means what it is? Equal energy. All orbitals are having equal energy after mixing up. Clear? And that type of hybridization we will call as a Sp2 hybridization. That three orbitals are formed. New three orbitals are formed. Those we will call as a Sp2 hybridized hybrid orbitals. Clear? How they form? And simple, I will take here one s orbital. Clear? Any two p orbitals. Clear? Two p orbitals. Clear? I am taking here px. This is the px and plus and py. I am taking here py. Clear? This is what it is now here py. And also another one is there. What it is pz. This is pz. But how many are mixed up here? This is pz. And any two p orbitals means one s and two p orbital, and they mix up and gives here three new orbitals. 1, 2, 3. I already mentioned hybridization condition means how many atomic orbital involved in the hybridization, and those many hybrid orbital will be formed. So here 3 are involved, so that's why how many hybrid orbital will form? 3 s and 3 sp2 hybrid. 3 sp2 hybrid orbitals will form. Hybrid orbitals. Clear? And what is that shape of these three hybrid orbitals? Trigonal shape. Clear? So you know what is the trigonal shape? Clear? What is the trigonal shape you already? This is trigonal. Clear? So I will write anything. So this is one Sp2 hybrid orbital, because I already mentioned how to write the hybrid representation of a hybrid orbital. This is the one Sp2 hybrid orbital, and the second one, this is another Sp2 hybrid orbital. Clear? And the third one, this is clear? How many Sp2 hybrid orbitals are there? Total 3. This is Sp2 hybrid orbital. Clear? All are Sp2 only. 1, and this is Sp2, and this is Sp2. Clear? So if I take here bond angle, what is the bond angle here? Bond angle is 120 degree. What is the shape of this hybrid orbital? Trigonal planar. What is the shape of this Sp2 hybrid orbitals here? Trigonal planar. And I already said what is the shape of hybrid orbital? Molecule shape also will be the same. Clear? Why? Because the overlapping orbital has to come in the same direction. Clear? Suppose if any orbital wants to if any orbital overlap with the Sp2 orbitals, they have to come in this direction only. In this directions only. So that's why these all bonds what will form. After overlapping, you will get covalent bonds. So that's why we said here covalent bonds are directional, but ionic bonds are non-directional. Clear? This is what it is now here. Trigonal. These are Sp2 hybridized orbital, and this Sp2 hybridized orbital involved in the bond formation. Clear? Suppose if I take one example, simple example, then we will get the clarity. So example, I will take the BCl3, boron trichloride. Clear? So boron means you already know what is the boron ground state electronic configuration, because you know only valence shell electrons involved in the hybridization. So that's why in this one valence shell you have to write 5. So that's why 2s2 and 2p1. 2s2 2p1 means you already know there 2 electrons are there, and here how many electrons are there? One electron are there here. But to form 3 bonds, boron should have how many unpaired electrons? 3 unpaired electrons, because only unpaired electrons involved in the bond formation, covalent bond formation. So that's why it is having only 1 unpaired electron, means boron has to form only 1 bond with the chlorine. But how many bonds it is forming here? 3 chlorine atoms are attached to the boron, means, and boron should form 3 bonds. 3 bonds means, and you have to write excited state. What it is here? Excited state. In the excited state, one of this electron jumps into the p orbital. Why it jumps? Because almost these energies of orbitals almost same. So that's why one of this electron will jump here. Clear, my dear? Now this is what is boron, and these 3 orbitals, one s orbital and 3 p orbital, involved in the hybridization. Clear? Because this is s orbital and these are what is p orbital. S orbital and p orbital, slightly there is a difference in the energy. So that's why when they mix up, all orbitals will have equal energy. So that's why they mix up first of all and gives how many hybridized orbital? 3 sp2 hybrid orbital it will give. So what is the shape? I have mentioned here already. This is the shape. Clear? So in the middle, what will be there? Here boron should be present here. So this is, you can write boron, or without boron also you can write it, no problem. Clear? Here 1, and here there is 2, and here there is a 3. Clear? So this is, what is the central atom here? Boron. This is, I am writing here for boron. Here boron will be there. This is for boron. Now these sp2, each one is having 1 electron or not? Each one is having 1 electron. Each one is having 1 electron. Clear? This is sp2 hybrid orbitals. Of which one? Boron. And this boron has to make a bond with which one? Chlorine. How many chlorine atoms are there? 3. You know that chlorine. What is the electronic configuration? 2s2, 2p, 5. And you know here how many electrons are there in the p orbitals? And 5 electrons. 1, 2, 3, 4, and 5. Clear? So that's why one of these p orbitals overlap with the one of the sp2 hybrid orbital of the boron. Clear? But how many chlorine atoms are there? 3 chlorine atoms. Each chlorine atom, this unpaired half-filled orbitals overlap with the, and here 3 sp2 hybridized orbital of boron and forms a 1 bond, covalent bond. Clear? So now this is overlapping. Clear? This is which orbital? One electron will be there, and inside. Now this is p orbital. P orbital of which one? Chlorine. This is what is known p orbital of chlorine, and another I will write. This is overlapping. This is p orbital of another chlorine, and this is p orbital of another chlorine. Total how many are there? Because here I already mentioned, and boron sp2 hybridized orbital are having 1 electron. Each sp2 hybridized orbital are having 1 electron, and this p orbital will have 1 electron. So that's why here in the between, how many electrons will be there? 2 electrons. 2 electrons means what? 1 bond. That is only. So that's why here this is a overlapping. You know, this is positive, positive, and positive. This small lobes will get the which charge? Negative charge. So this is positive, and these are positive. And you know, positive, negative, positive, negative. Overlapping is which overlapping here? Positive. All cases overlapping is positive overlapping. When positive overlapping takes place between the orbitals and bond formation takes place. If negative overlapping is there, no bond formation. Zero overlapping is there, no bond formation. So that's why what you will get, my guys. This is boron. Actually we have to write here boron. but if you write it not looks good, so that's why I'm not writing here. Now what you are getting is, this is boron, and here you are getting chlorine, here you are getting chlorine, and here you are getting chlorine. So what you are getting, BCl. Clear one? So what is here? BCl. This is what is the shape of this molecule, trigonal planar. What is the shape of this molecule? Trigonal planar. Clear one? Now, and I mentioned here sp2 hybridized orbital, and each hybridized orbital contains 1/3 of the s character and 2/3 of the p character. 2/3 of which character much? I will write here. Clear? So hybrid orbital, each hybrid orbital, sp2 hybridization. sp2 hybridization means total how many orbitals are there? 3 orbitals are there. What is the s character? Percentage of s character if you want to calculate. 1 by total orbital. S orbital 1. Total orbital how many? 3. 1 by 3 into 100. That is percentage of s character. How much more here? 1/3 into 100. Almost 33.3%. What is the p character? Percentage of the p character of each hybrid orbital. How much p character? How many p orbitals are there? 2 total how many? 3 into 100. Almost 66.66%. And this is about the what it is marked here, sp2 hybridization. So next one is sp3 hybridization. sp2 over, sp over, and the third one is what it is marked here, sp3 hybridization. In the sp3 hybridization, same, there 1 p orbital and 1 s orbital and 2 p orbital. Here how many you have to take? You have to take the 3 p orbitals. Clear? Belongs to the same shell of the atom are mixed together and form. How many orbitals you will form? 1s and 3p. Total how many? 4. 4 new equivalent orbitals are formed. And this type of hybridization is called which hybridization? sp3 hybridization. And that newly formed 4 orbitals we will call as a sp3 hybrid. And see the now what is the how it will be formed, and I will write here 1s orbital and plus, and here p orbitals. Just assume this is a px orbital, and here there is a py orbital. This is, and this is a py orbital, and the next one is pz orbital. So this is pz orbital. This is pz orbital. And all these 3 atomic orbitals of a atom and mixed together and form how many orbitals? How many hybrid orbitals? 4. Because I already mentioned how many atomic orbitals involved, and those many hybrid orbitals you will get. Clear? So that's why you will get 4 sp3 hybrid orbital. You will get what is here? 4 sp3 hybrid orbital, and all these 4 sp3 hybrid orbitals are having equal what is here energies and identical shapes. Clear? So this is sp2 hybridized orbital. And what is the shape of this sp2 hybridized? Clear? You know that tetrahedral. sp3 hybridized means I already mentioned here, only the shape they have given. What is it? Tetrahedral or sp3 hybridization means this 4 sp3 hybridized orbital will have tetrahedral shape. And how that tetrahedral shape means this is. Clear? So this is the tetrahedral shape. This is one lobe, and here there will be a lobe. Clear? So next one is this is one, it will go back actually. One is it will be there back side. You see 3 lobes are there, and this will be back side actually. Clear? So what I will write, and that I will write. Clear? So this is back side. Back side means just I will write here just one lobe. Clear? So this is what it is. How many? These all are sp3 hybridized orbitals. How many? So what is the shape of this sp2 hybridized orbital? Tetrahedral shape. This is what is the shape? Tetrahedral shape. Now we will take one example. Previous we have taken CH4. You know, one example I have taken failure of orbital concept, orbital overlap concept. There I have discussed CH4 example. In that one, what happened? And 3 p orbital and 3 s orbital overlap and form and 3 CH bonds, and those CH3 bonds are separated by how much angle? 90-degree angle. But we already know in the CH4 what is the angle? 109.5 degree. So that's why that simple. Without means if you don't take the hybrid orbitals, simply you overlap. It means simply atomic orbitals are involved in the bond formation. Our atomic orbitals are overlapped together. Simple atomic orbitals. Then and it fails to explain the shapes of many molecules. So that's why hybridization concept here. Is so that hybridization concept has been introduced. Clear? So that's why this hybridization concept explained very clearly the shape of the CH4 molecule. Clear? See now, what is the first one here? Carbon. This is carbon. Clear? So carbon ground state electronic configuration, GS electronic configuration. 2s2, 2p2, because carbon is belongs to 4th group or 14th group. 14th group means 4 electrons. And here there will be a 2 electrons, and here there will be a how many electrons? 2 electrons. How many unpaired electrons are there? 2. 2 unpaired electrons means carbon should form how many bonds? 2 bonds only. But carbon is forming how many bonds here? 4 bonds. 4 hydrogen means 4 bonds. So that's why we have to write the excited state. The excited state, one of these electron will enter into the p orbital. So totally how many orbitals we have? 4 orbitals, and these 4 orbitals overlap because this is 1s orbital and 3p orbital. So that's why, and slightly they have difference in the energy. Slightly they have difference in the energy. When only these atomic orbitals involved in the overlapping of hydrogen, then what will happen? The shape of the stick means the structure of the molecule will be different, because that is we have discussed. Here carbon is there and 3 hydrogens direct overlapping. There will be another hydrogen, but what is the bond angle here? 90-degree bond angle here. But what is the actual bond angle? 109.28 minutes or 5 degrees. We can simply write. That's why we should not take direct overlapping of atomic orbital. So we have to take which one? Hybrid orbital. So that's why. And these 4, 1s. And here how many 3 orbitals are there? How many p orbitals are there? 3 p orbitals are there. And these p 1s orbital and 3 p orbital undergo mixing or combination, and it gives how many orbitals? Now 4 yes 1s and 3 p orbital. 4 sp3 hybrid orbitals. Clear? Now this is the central atom. Clear? So what is the central atom here? Carbon. Carbon is having how many sp3 hybridized orbital? 4. That I will write. This is one. Small lobes I am not writing here. Directly I am writing. And this is what it is here. If you want to write here, this is carbon. We cannot write that second lobe here exactly. So that's why I am not writing. So I am writing only the one lobe. If you don't write here carbon, see like this lobe will come. But in the middle, which one is there? Carbon is there. So I'm not writing here. So these are what is each sp2 sp3 hybridized orbital is having one electron. Clear? Unpaired electrons are there or not? Unpaired electrons are there. Then they involved in the overlapping. Overlapping with which one? Hydrogen, because hydrogen is also having. Hydrogen is also having what it is? Hydrogen is 1s, means one half filled orbital, and this half filled orbital overlap. Clear? So here you will get this is hydrogen 1s orbital, hydrogen 1s orbital, hydrogen 1s orbital, and hydrogen 1s orbital overlap. Clear? So this is which orbital? sp3 hybrid orbital. This is what it is, one s orbital, 1s orbital. Here bond. This is positive. All these are which for what it is, one positive. Clear? So here positive, and this is positive. That is. Then what it is, one positive overlapping. Positive overlapping means what will happen? Bond formation. Simple. You see, all these 4 orbitals. You simply I will write one off here. Roughly I will write. See, this is 4 sp2, sp3 hybridized orbital. Here what it is there? 1 electron, 1 electron, 1 electron, and 1 electron. Each are having one electron. So now hydrogen is having 1 electron, and it gives 1 electron. pair up, and here also hydrogen is giving 1 electron, and here also hydrogen is giving 1 electron, here also hydrogen is giving 1 electron. And carbon, this is what it is now, all are hydrogen. And carbon and hydrogen between how many electrons are there? 2 electrons. 2 electrons means what it is now? 1 bond formation takes place. That is covalent bond. So this is orbital concept. So that's why we are writing in this way. Clear? That is. So now you will get here carbon and how many bonds you will get hydrogen. Sometimes they will ask. So what is the sigma bond? How the sigma bond? Which orbitals are involved to form the sigma bond between the carbon and the hydrogen? One is Sp3 and another one is which one? Yes, that is. So here these are hydrogen, hydrogen and hydrogen. These all are which one? Sigma bonds only formed. Clear? What is the sigma bond here? Sp3, yes. Here also what it is? Sp3, yes. These all are what is? Sp3 and this is yes, sigma bonds only. So this is the structure of what it is. Clear? So if I take this one, what is the bond angle here? Suppose if I take, this is axis. What is the bond angle here? 109.5 degree. What is the shape of this molecule? Tetrahedral. What is the shape? Tetrahedral. I already mentioned the shape of this molecule is A. The shape of this Sp3 hybridized electron is A. Tetrahedral. Finally, this is, you see, I am talking about only the hybrid orbital. Hybrid orbital shape is what it is? Tetrahedral. And what is the molecule shape here? Tetrahedral only. That's why I said, what is the shape of the hybrid orbital? And that shape will be, that molecule also will have the same shape. So that's why here also what it is here? Tetrahedral shape. This is tetrahedral shape. Clear? Now, and I will write here each hybrid orbital. How many hybrid orbital we have? 4 hybrid orbital. Each hybrid orbital S character how much we have to calculate. So you know Sp3 hybrid orbital. Each hybrid orbital S character is how many total are there? 4. Total 4. S orbital how many? 1 into 100. How much it is? 25% S character. And what is the P character of each hybrid orbital? This hybrid orbital will have S character how much? 25%. P character how much here? And P how many are there? 3 by 4 into 100. How much here? 75%. So this hybrid orbital, one hybrid orbital will have the 25% character of S orbital and the 75% of the what is not P orbital. Each hybrid orbital and will have S character 25 and P character 75. And this is about what it is here, tetrahedral or Sp3 hybridization. So next one we have to discuss about hybridization and shape of the what it is here, NH3 molecule. First of all, you have to write what is the central atom, and central atom orbitals, valency orbitals will involved in the hybridization and after then overlapping. That is the concept for all molecules. Okay. So now nitrogen you already know what is the nitrogen electronic configuration at ground state. Ground state, 2s2, what it is here, 2p3, 2s2, 2p3. Because nitrogen belongs to 5th group or 15th group, means 5 electrons should be there in the outermost shell or valency electrons. So how many electrons are there in the s orbital? There are 2 electrons. And in the p orbital, how many electrons are there? There are 3 electrons. Clear? That is. Now, nitrogen has to form how many bonds? 3 bonds. 3 bonds means how many unpaired electrons should be present? 3 unpaired electrons. So it is having. So that's why you need not to write the excited state here. Got my point? When you have to write the excited state, and if here surrounding atoms how many are there, and here how many unpaired electrons are there, you have to check. Previous I have taken carbon. Carbon is 2s2 2p2. 2s2 2p2. Carbon valency how much? Carbon valency 4 means carbon always form how many bonds? 4 bonds. But if you take in this case, and how many unpaired electrons are there? 2 unpaired electrons only present here. 2 unpaired electrons means carbon should form how many bonds? 2 bonds. But it is actually forming how many bonds? 4 bonds. So that's why you have to write the excited state here. Because 4 unpaired electrons are there, so carbon will form how many bonds? 4 bonds. But here, not required excited state. You can take only ground state. Why we can take only ground state here? That is the reason. Because here nitrogen is forming 3 bonds. 3 bonds means nitrogen should have 3 unpaired electrons. And these now orbitals, I already said all valency orbitals will involved in the hybridization. If there is no pi bond, only single bond means all will form. That also pi bond also we will discuss. Clear? So this is about means here one s orbital and how many p orbitals are there? Px, py and pz. 3 p orbital and overlap. You will get 4 sp3 hybrid orbital. I already mentioned in the means when we have discussed about the conditions and the salient features of hybridization. Paired orbitals also involved in the hybridization. Clear? That is important. Clear? But they will not involve in the overlapping. To involve in the overlapping, off-filled orbitals must be required. Clear? So now how many orbitals are there? And 4 sp3 hybridized orbital. sp3 is there. Then you have to write the structure like what it is, tetrahedral. Clear? So here nitrogen is in the middle. Where is it? Nitrogen is in the middle. Then what you have to write? Otherwise I will write here. This is hybrid orbitals. One will be there back side. Clear? That I will write. This is what is this is nitrogen. Clear? This is what it is here, nitrogen. Central atom is what it is here, nitrogen. Clear? If you want, you can directly write by taking the nitrogen. But if I write the nitrogen here, I cannot put these small lobes. Clear? So that's why I am writing it this way. So what is the central atom here? Nitrogen. Clear? So nitrogen is having, see, total how many orbitals are there? 4 orbitals. And in that 4 orbital, 4 sp3 hybridized orbital, one of the sp3 hybridized orbital is having non-bond pair electrons, and the remaining 3 sp3 hybridized orbitals are having one single electron. See, this is what it is, lone pair, or you can say non-bonding electron. Non-bonding electron. This is non-bonding electron. Clear? So these electrons are what we will call. These electrons we will call as a bonding electrons. These unpaired electrons, single electrons involved in the bond formation. Clear? So this is about what it is, nitrogen. Now hydrogen has to overlap. Now see, I will write here the same picture. Same structure I will write. So here there will be, and there will be a back side one lobe. Clear? This is one back side. Clear? Nitrogen. Here what it is there, electrons are there. Here one electron is there, one electron is there. So now hydrogen overlaps. Clear? This is what it is, hydrogens. Clear? So hydrogen give one electron and it is having one electron. So these involved in the bond formation. Clear? Now you see this non-bonding electron, is it involved in the any bond formation? No. So these 3 electrons are there, they involved in the bond formation. Finally what you are getting? You are getting picture is. So what it is one here? Hydrogen here. There is one hydrogen and hydrogen. What should be the shape of the molecule? Because it is 4 sp3 hybridized orbitals are there. What should be the shape? Tetrahedral. But you know that. Here what is there? Lone pair of electron. I already discussed. Lone pair of electrons are there. Here what is there? We will call bond pair of electron. Lone pair bond pair repulsions will be more. If a lone pair is present, then automatically the shape of the molecule distorted. Means it is converted tetrahedral to it will move pyramidal. The shape changes from the tetrahedral to pyramidal. And bond angle, tetrahedral means 4 sp3 hybridized orbitals are there. We will say this is tetrahedral. Tetrahedral means what should be the bond angle? 109.5. But what is the bond angle here? We have already discussed previous. What is the bond angle? 107 degree. So why means this is tetrahedral shape is not coming, and also this molecule not acquire the tetrahedral shape, and also bond angle is not 109.5 because of presence of lone pair of electrons. And this is about what it is here, NH3 molecule. So what is the hybridization of NH3 molecule? Sp3. What is the shape of the molecule here? Pyramidal. Because of which one? Presence of lone pair. Clear? In the same way, and we will take water molecule H2. Water molecule. Clear? So H2, what is the central atom here? Oxygen. Oxygen means first we write oxygen. Ground state. What is the ground state oxygen? 2s2 and 2p2. 2p2 means you know here in the s are 2 electrons and the p orbital how many electrons are there? 1 and 2. Clear? So we have to write the exact state or not, you have to check. So oxygen is forming how many bonds? 2 bonds. How many unpaired electrons are there? 2 unpaired electrons. You need not to write the exact state. So these 3 orbitals. What is my here? These 3 orbitals involved in the overlapping. Clear? Then what you will get here? You will get the compound here 1s2, 2s2, 2p. So here I made a mistake. Oxygen, say what is the electrons here? 2s2 or 2p4. So here how many electrons I have to write? So here 3 and what it is now 4. So how many unpaired electrons are there? 2. So that's why you need not to write that because oxygen is forming 2 bonds, because you need not to write the exact state. And these 4 orbital involved in the means hybridization. Mix it together 4 hybrid orbital and form 4 sp3 hybrid orbitals forms. sp3 hybridized hybrid orbitals. 4 atomic orbitals involved in the hybridization and form 4 sp3 hybridized orbital. You know what is the 4 sp3 hybridized orbital means? Same like previous what I have written. So this is 1 and this is, you have to write. Clear now? So here there is here back and roundness. Clear? So these are lobes, small lobes. Clear? So this is what is the hybridization here? sp3. How many sp3 hybridized orbitals we have? 4. All these are sp3 hybridized orbitals. And among these, one of the sp3, 2 of the sp3 hybridized orbital will have the paired electron, and the remaining 2 sp3 hybridized orbital will have the unpaired electrons. So here there is a 1 paired electron, and here also paired electron, here 1 electron, and here 1 electron. Clear? So you know that. And these unpaired electron hybrid orbitals only participated in the bond formation, or you can simply say overlapping. Clear? So this is what it is my sp3 hybrid orbital of which one? This is oxygen. What is the central atom here? Oxygen. So this is for oxygen. But now, and it has to form have what is bonds here? I mix 2 bonds with the hydrogen. These orbitals will involve. Will they involve the hybridization? No. Because why? These are what it is lone pairs. Are non-bonded electrons. Lone pairs never involved. Means they will not involve in the covalent bond formation. These are lone pairs. Clear? So are non-bonding electrons. We can say these are what it is. These 2 are bonding electrons. Means they participate in bonding electrons. They participate in the bond formation. Now write how we will get. See, this is central atom is what it is here. This is this is low will be back. Clear? So now here 2 electrons are there. Here what is there? 1 electron. These will involve because hydrogen is having what it is one. Here a hydrogen is having 1s1 means 1 half filled atomic orbital, and here half filled hybrid orbital, and these involved in the bond formation. So here how many electrons will be there? 2 electrons, because hybridized orbital is giving 1 electron, and this is another electron. So what will happen here? Oxygen, 2 lone pair of electrons, and here. So due to actually what is the shape of the molecule? Because sp3 means shape of the molecule should be what it is, tetrahedral. But due to here 2 lone pairs, and due to these 2 lone pairs, the bond, the shape of the tetrahedral is changes to bend shape. I already said two bond pairs and two lone pairs. What is the shape, man? Bend shape or angular shape or V shape. Clear here? So that is here the bond angle if you take, and how it will be formed. You see, oxygen is a central atom. It is having two lone pairs. Here one lone pair is there, and there is a one lone pair, and here there is a bond here, oxygen here, and OH and O, oxygen H and H. This is. So what should be the shape of this molecule? Bend shape, because of lone pair of electron. What is the bond angle here? 104. Because I already mentioned why it is 104 bond angle. So this is about the what it is here, H2O molecule hybridization and shape. How many bonding electrons are bond pairs are there? These we will call bond pairs. Two bond pairs, two lone pairs. Bend shape. Here you see one lone pair and three bond pairs. What is the shape? Pyramid. Three bond pairs and one lone pair. Pyramidal shape. And this is about the hybridization of the lone pair and bond pair containing molecule. Previous we have discussed only bond pair, but here along with bond pair, lone pairs also. What is the shape that we have discussed? So next one is other examples of Sp3, Sp2 and Sp hybridization. I will write one by one. And first one is Sp3 hybridization in C2H6. What is the C2H6 now here? Ethane. What is the C2H6? Ethane. The formula of ethane you already know. This is ethane. Clear? This is what it is, one ethane formula. Clear? That is clear. Same. Now in this case, in the ethane, in the formation of ethane, both the carbon atoms undergoes Sp3 hybridization. Both the carbon atom undergo Sp3 hybridization. Clear? Don't bother about how this Sp3 hybridization it comes, and we have formula to calculate hybridization of each and every molecule. I will say one simple trick also. By seeing the molecule and the molecule undergo which hybridization, then we can easily predict. Clear? So we have formulas and also trick that we will discuss later. Clear? So here you see, just assume here carbon is there. Carbon is forming how many bonds over here? 4 bonds. 4 bonds means Sp means all are single bonds, so it is a Sp3 hybridization. That also one simple trick. And later we will discuss all this. So each carbon atom undergo Sp3 hybridization. Clear? So this carbon is also Sp3 and this carbon also Sp3. Clear? So one carbon Sp3 hybridized orbital and overlapping with another Sp3 hybridized orbital of one Sp3 hybridized orbital of another carbon and form one bond. Clear? See, simple. So both the carbon atoms are having which one? Both carbon atoms undergoes which one here? Sp3 hybridization. I will write here one carbon. One carbon Sp3 hybridization means here in the central carbon will be there. Clear? So for our convenience, I am writing like this. Clear? So you know these all are, and there will be a one loop back side. Clear? Total how many? 4. This is for one carbon. 4 Sp3 hybridized orbital. Clear? These all are which one? 4 Sp3. This is one carbon. Another carbon is there here. Another carbon also what it is one? Sp3 hybridized orbital. What happened here? Has to form sigma bond. You already know carbon. Carbon what it is? Carbon is here 2s1, 2p4, 2p4. Clear? So this is 2s and here 2p means 2s to 2p3 excited state. S orbital and p orbital total how many are there? 4. 4 means here 4 sp3. These 4 atomic orbital undergo hybridization and forms 4 sp3 hybridized orbital. Clear? Okay. Now this is for one carbon. Another carbon is there, same like this only. And now each carbon is having one unpaired electron, sp3 hybridized orbital. Each sp3 hybridized orbital of the carbon having one unpaired electron. Now another carbon, one sp3 hybridized orbital overlap here. This is clear? So this is another carbon. Clear? All these are what it is, sp3 hybridization only. This is sp3 hybridization, sp3 hybridized dimethyl. All these are sp3 hybridized dimethyl. Now you see here, this is carbon and this is carbon. So we have each carbon is having 4 sp3 hybridized dimethyl. So one of the sp3 hybridized dimethyl of one carbon overlap with one sp3 hybridized dimethyl of another carbon and form one bond here. Which bond here? Sigma bond along the internuclear axis. What my bond here? One sp3 hybridized dimethyl of one carbon overlap with sp3 hybridized dimethyl of another carbon along the internuclear axis. Overlap along the internuclear axis and forms one sigma bond. Clear? Now each means here 3 sp3 hybridized dimethyls are there. The remaining each sp3 hybridized dimethyl of each carbon overlap with the hydrogen atoms along their respective internuclear axis and forms which one? It forms one sigma bond. Clear? Here what is it? Here all are having one unpaired electron here. Clear? So hydrogen, hydrogen is having, each hydrogen is having one s electron, single unpaired electron. Here also unpaired, off-filled orbital, and here off-filled. You know what it is, hybrid orbital. They overlap and form a sigma bond. Here there is a one hydrogen. Here one hydrogen. There is a hydrogen. These are all involved in the what it is, overlapping with hydrogen. Then here what it is, pair of electrons will be there. Pair of electron means what it is, one bond. This is only. So this is what it is, here. Yeah. So this is, you see, this is the carbon. First of all, which bond is formed? Sigma bond. This is sigma bond. All are sigma bonds only. Clear? Sigma bond. And here there is a one hydrogen. And here also there is a one hydrogen. And here also what is one hydrogen. Here hydrogen and hydrogen and hydrogen. This is what it is, ethane molecule. Clear? So what is the bond angle? If you take bond angle here, any bond angle, clear? I have written like this, but actually it is not exactly like this. Clear? So what is the bond angle means? The bond angle here, if you take any bond angle, CH bond angle, these bond angles are how much more here? The bond angle is 109.5 degree. Clear? So this is about the what it is here, sp3 hybridization. Clear? So what is the bond angle here? This is the reason how the molecule is formed. Clear? And next we will go for sp2 hybridization. Clear? So this is what it is, molecule. Exactly what it is here, they are like in this way. I have written here, if I write like this, you will say 90 degree. But just I have written like this. But what is the exact here? This is. So like this will be there. Carbon, and here hydrogen, and here hydrogen, and here there will be a hydrogen. What is the bond angle then? 109 degree, 109.5 degree. So these all are which bond here? This is all are sigma bonds. Here all are these sigma bonds. Clear? So this is about what it is here, sp2 hybridization in C2H4 molecule. And next one is sp2 hybridization in second one, sp2 hybridization. I will write one example. Clear? Another one, sp2 hybridization. sp2, second one is sp2 hybridization. sp2 hybridization. sp2 hybridization in C2H4 molecule. What it is here? C2H4 molecule. What is the C2H4 molecule? Ethene. You might have studied. This is the molecule H and H, double bond H and H. This is clear. Now in the formation of, just I have written, we will get this picture here. And in the formation of ethane molecule, what is the name of this one? Ethene. In the formation of ethane molecule, both the carbon atom undergoes sp2 hybridization. Here what it is here? Both carbon atoms undergo which hybridization? sp2 hybridization. Which hybridization? sp2 hybridization. Clear? Why sp2 hybridization? Because you know carbon excited state, electronic configuration, here 1 and here what it is 1. 3 electrons are there here. So you may ask, sir, here already 4 electrons are there. These 4 electrons will undergo hybridization and to form 4 hybrid molecules, 4 hybrid orbitals. But I said here sp2 hybridization means 1s and 2p orbitals involved in the hybridization and forms 3 sp2 hybrid orbitals. 3 sp2 hybrid orbitals. So why means you see here which bond is there? One is sigma bond, another one is pi bond. I already mentioned hybrid orbital never involved in the formation of pi bond. Previous I have given conditions, there I have given, and salient features I have given, their features I have already given. Yes, it means hybrid orbital only involved in the sigma bond formation, not in pi bond formation. That point you have to remember. So that's why, and here one pi bond has to form. One pi bond has to form means hybrid orbital will not involved in the formation of pi bond. So that's why one unhybrid orbital should be present here. This unhybridized, or simply we can say pure orbital, involved one carbon unhybrid orbital, another carbon also will have one unhybrid orbital, and that involved in the formation of pi bond. That involves in the formation of which bond? Pi bond. Got my point here? So that's why here S3 sp2 hybridized orbital. Clear? Now I will write how the bond formation takes place. Center atom, carbon is having what it is here? sp2. This is sp2 means this is clear? sp2 means we have already discussed in the this is sp2. Clear? So 1 and 2 and this is for this and this is for this and this is for this. Clear? This is sp2 hybrid orbital of carbon. This is one carbon. Got what? Here one unhybrid orbital will be there. That is one unhybrid orbital. So we just assume this is a px because this is internuclear bond formation takes place. Z orbital will involve. So just I assume here px orbital. Then this is for what it is here? This is sp2. All these are what it is sp2, and here sp2. But this is which orbital? Unhybrid orbital. That orbital we will call as a px orbital or py orbital it can be. Clear? So now another one I will write here. Another one means what it is? Another carbon. So what will happen here? Another carbon and one hybrid among the three. One hybrid orbital of one carbon overlap with the one hybrid orbital of another carbon along the internuclear axis and form one sigma bond. Clear with this? That is here. This is clear. So this is this is 3 hybridized orbitals. Clear? This is 3 hybridized. Clear? This is also will have one px orbital, unhybrid orbital. These 3 are what it is? Hybrid orbital, and another one is what it is? This is unhybrid orbitals. Got my point here? Now this is one hybrid orbital of carbon, one carbon overlap, one hybrid orbital of another carbon along the internuclear axis and form which one? Sigma bond. Clear? Now and two orbitals, two hybrid orbital of each carbon overlap with off-filled atomic orbital of hydrogen along with their respective internuclear axis and forms sigma bonds. Clear? So this is this is, and these hybrid orbitals, these are which orbitals? sp2, and this is also what is sp2, and this is sp2, and this is also what is sp2 hybrid orbital. Now each one is having one electron. Clear? Here also it is having one electron, and this is one electron means, and one electron. Here one bond formation takes place. Clear? Now here hydrogen overlaps here. Hydrogen overlap. This is sp2 hybridization. Clear? Hydrogen overlap. Then one bond formation takes place here. Here also what it is? Hydrogen overlap. Two electrons will be present here. This is clear? So sigma bond. This is one sigma bond. Here one sigma bond. Here one sigma bond. And here there is a sigma bond. And there is a sigma bond here. Clear? Now these orbitals are having. You know, this is what it is? Unhybrid orbital. Unhybrid orbital. Which orbital that is? It can be px or py. Clear? I have taken here px. Now these overlap. These what here overlap and forms which one? And this is the what it is here molecule. We can simply write, and here what is CH. See what H and H here. Got my one? Here what is there? One sigma bond is there, and one pi bond is there. Sigma and pi bond, and carbon, hydrogen and hydrogen. These all are which bonds? Sigma bond, and this is what is what? Pi bond. If I write separately, one is first of all formation of sigma bond, and after that formation of pi bond. Then how I will write? You see this molecule. First of all, one carbon is having sp2 hybridized orbital. Clear? So this is sp2 hybrid orbital. Clear? Neatly, right? This is one carbon. All are which one? sp2, sp2 and sp2 hybrid orbital. Another carbon I will write. This is clear? So here clear? So this is another carbon. This is what it is, sp2, sp2 overlapping. This is sp2, sp2. Here also sp2. Here also sp2. So this bond is what it is, sigma bond. All these have single unpaired electron. Yeah. So this is which bond? This is sigma bond. Here what will happen? Hydrogen, hydrogen. Here what will happen? Hydrogen, and here hydrogen. These all are sp2 hybridized orbital. Clear? So here hydrogen, 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 and hydrogen. Clear? These are hydrogens. I am writing separately sigma bonds and pi bond. Clear? Then what will form here? You see carbon. This is the carbon. Clear? So this is a sigma bond, and here there is a sigma bonds. All these are sigma bonds. Clear? Now pi bond I will write. Now here one px orbital is there, unhybrid orbital. That is only means here hydrogen and hydrogen. I have written here, and this is C, hydrogen and hydrogen. Here which orbital will be there? Px orbital is there with the carbon. Clear? So this is one electron and electron. So this overlap, side wave overlap of the unhybrid orbital of the each carbon, and forms which one? And forms pi bond. So then finally what you will get here? You will get, you see, hydrogen, hydrogen, and here sigma bond, and it is pi bond. Here hydrogen and hydrogen. Clear? So now if you take these all are present in one plane, and this pi electron cloud present above the plane and below the plane. If I write like this, you see this molecule, I will write in this way. Hydrogen. Clear? So here there is a sigma bond. Clear? So there is a here hydrogen, and here hydrogen. Clear? So this is all these molecules involved in the what it is here. They are in same plane. Clear? And above the plane and below the plane, which one will be there? Pi electrons will be there. So above the plane, there will be a which one here? There will be a pi electrons. This is clear. So above the plane and below the plane. These are which one here? This is about what it is here. C2H4 molecule, how it has formed. So another last example here for sp hybridization. I will give another example. What is that one here? C2H2. C2H2 means what is ethane. What is the formula of ethane? Ethyl means which one? Triple bond. Ethyl means what is which one? Triple bond. If triple bond is there, what is the hybridization of carbon here? Sp. Okay, that is we will discuss. See now, in this one, carbon is forming. Between the carbon, how many bonds are there? 3 bonds. 3 bonds means 1 sigma, and remaining 2 are which one? 2 pi bonds. What my point here? How many pi bonds are there here? 2 pi bonds, and here sigma bonds. And 2 pi bonds will not formed by the hybrid orbital. These will be formed by unhybrid orbitals. Means if I take carbon here. Carbon, what is the excited state electronic configuration here? 1 electron in this 2s orbital and another 3 electrons are present in 2p orbital. Clear? And now, with how many orbitals involved in the hybridization? Only 2. Why? Remaining 2 electrons, these 2 orbitals should involved in the formation of what it is? 2 pi bonds. Clear? 2 pi bonds are there means 2 electrons, unpaired electrons of one carbon, another unpaired electrons of another carbon, they overlap and forms what it is? Pi bond. So that's why here only one s and p orbital involved in the hybridization. These are unhybrid orbital which are involved in the formation of what it is? 2 pi bonds. Got my point? So now, so here how many orbitals will be get? You will get 2, 1 s and 1 p. So that's why 2 sp hybrid orbitals will be formed. Hybrid orbitals, and these 2 sp hybrid orbitals involved in the sigma bond formation. Clear here? So now how it will be? 2 carbons are there. Each carbon here, both carbons in C2H2 undergo what is here? Sp hybridization. Sp hybridization. Here. So now I will write one carbon. This is one sp hybrid orbital. Another one is this is one sp hybrid orbital. Clear here? So this is sp hybrid orbital. This is sp hybrid orbital of one carbon. Another carbon is there. One sigma bond has to form. One sigma bond with the carbon between the carbon and one sigma bond between the carbon and the hydrogen. Means this is involved in the this is clear. This is one carbon. This is one carbon. One sp hybridal of one carbon overlapping with one sp hybridal of another carbon along the internuclear axis and forms what it is? Sigma bond. And here this orbital sp hybrid orbital, this is sp and this is also what it is? Sp, and this is also what it is? Sp hybrid orbitals. Clear here? So now here which bond will be formed? Sigma bond will be formed. Clear here? So here one sp is there, here one electron will be there, and here this one electron, hydrogen. Clear? And here hydrogen. Another sigma bond formation takes place. Clear? This is hydrogen and this is what? Hydrogen. Sigma bond. Here one sigma bond and here one sigma bond. Now we have here 2 sp unhybridized orbital. So one is this is one. Clear? Suppose this is just assume px, and another one is what should be there? There should be a py. Clear? Here also there should be another carbon. We will have px orbital because I have written for only one carbon. Another carbon is there, no? That is, and here also I have written this. So there will be this is. Clear? Then what happened? Already here sigma bond is formation takes place. Now pi bond. Pi bond means what is it? Pi bond always takes place between the unhybrid orbital of the same unhybrid orbital. Px is there. Px overlap. This is Px is here and Px is here. This is overlap. Which bond? Pi bond formation takes place, and here overlap. This is py. Assume this is what is here? Px, and this is py. This is what is here? Yeah, py. One unhybrid orbital of the py overlap in the side way with the one py orbital of another carbon. This is overlap. Clear? So this is So what which bond will be formed? Here you will get the pi bond, and here what is pi bond. So how many pi bonds will form here? Overlapping here. I have written here pi bonds means both are same only. So clear one? So this is overlapping, upper overlapping and downward overlapping. So this is what is sideway overlapping. Then what you will get here, you see. So first of all, carbon and carbon one sigma bond, and there is a carbon and hydrogen one sigma bond. For this one, carbon and hydrogen one sigma bond. Px one double bond, and this is one double bond, and py one double bond. This is the shape of the bond. Clear no? How you will. Clear no? So this is one example of what is here Sp3 hybridization. What is that example? Ethane. Remember, simple. If carbon is having all single bond around the carbon, then what it is all single bonds only. Ethane. All are which one? Single bonds. Carbon should be Sp3. If any double bond is there between the carbon, double bond is there between the carbon, then those carbons will have Sp2 hybridization. What is the hybridization of those carbons? Sp2. If triple bonds are there between the carbon, and then those carbons undergoes Sp hybridization. This is about what it is hybridization.